Hi everyone. So we were on the last part of this example here where we are to now draw a position versus time graph for the entire round trip. Note this graph can look in an infinite number of different ways. It'll all have the same shape, but because we're not told where the initial position is, we in our problem solved it saying that this person starts at the location of 0, which seems reasonable, and that's probably what most graphs will show. You can technically start this person running from any location, any position. But we'll play it simply and say the person starts at. All right. So sorry it's a little chopped up, but we're going to go with it here. So I've created this position versus time graph. Well, I haven't graphed anything yet, but I set up the coordinate system. So I have on my x, or I should say my horizontal axis, time in seconds. So that's what I labeled here to the right, and every tick mark is 10 seconds. And looking at our kind of diagram here, right, we're running 10 seconds, then 25 seconds, then 125 seconds, giving us 155 seconds total. So that's why I went to 160 seconds on my horizontal axis, and on my vertical axis we have position, since we're making a position versus time graph. And I know for my diagram, we travel to the 100-meter position and then back to our original location. So our maximum position we're going to have is 100 meters. All right, so that's why I kind of had my graph axes the way they are. That way I'm not kind of wasting any space. All my graph is not located to, let's say, one little tiny corner of my graph. You really want to be able to easily read things on graphs. All right, so let me change to a different color. Let's go with blue. All right, so in the first kind of portion of this person's travels, they travel from time equals 0 to time equals 10 seconds, and they move at 5 meters per second. All right, so we know then that the person has traveled 50 meters. And we also know that because the problem tells us. So there's my starting location and 50 meters at the 10-second mark. All right, and we can connect those with a straight line. And there we go. All right. So then the next part, where do we go next? The person travels from the 50-meter location to the 100-meter location in 25 seconds. So that's going to be at the 35-second mark. So 10, 20, 30, and halfway is 5. And we are at 100 meters at that time. So that's approximately right there. So let's connect that with a line. We're doing straight lines here because we're moving with constant velocity. All right. Oh, let's make that a little longer. Close enough. Right. So the person's not speeding up or slowing down. The only place where they are technically doing that is at, our points here and here, because we're changing our speeds almost instantaneously. This is called something called instantaneous acceleration. We'll get more into that next lesson. But for right now, during those travels, they're moving at a constant rate. And then the person travels from the 100-meter location to the 0 location. So we're traveling back to 0, and it takes 125 seconds from that one moment. So that's going to be at the 155-second mark. We'll be back at 0. And let's draw our final straight line because they're moving with a constant velocity of negative 0.8 meters per second to do that. All right, so then here we have created our position versus time graph for this motion. I hope that was helpful. And yeah, so just to kind of summarize some new quantities we learned from this lesson, we talked about position, which we usually use the symbol x to represent it. It's a measure of distance or length, and it has SI units of meters. Similarly, we have displacement, which is our change in position in a certain direction, hence why the symbol x here is in bold, because it's a vector quantity, unlike position, which is a scalar. We also have velocity, a vector quantity, which is distance over time, which has units of meters per second. And we also have speed, which also is a measure of distance over time, but not including any direction, and has units of meters per second. All right, so I hope that was helpful, and have fun practicing some problems to become more familiar with using these notations and graphing these quantities.